Hello to everyone, welcome back again into our video. Today we're going to look at geography, specifically on slope aspects. Okay, yes, we're going to look at slope aspects. Okay, so this is our diagram, figure 1.3, which shows aspect in southern hemisphere and answer the questions that follow. So this shows slope that is in southern hemisphere. Okay, yes, I repeat again, the slope is in southern hemisphere. Okay, so I think you know the rules. Okay, yes, okay, so let's jump to our very first question. The very first question says 1.3.1, define the term aspect. Very easy and straightforward. Okay, so an aspect is a situation whereby a slope is facing, or a direction which slope is facing. So that's an aspect. Okay, yes, you can just say this is this is a term that describe a specific slope, or whereby the specific slope is facing. Okay, that's an aspect. Okay, meaning that if it's facing on that typical direction, that basically means that it's receiving the sunlight in that typical direction. Okay, yes. So that's aspect. Simple, straightforward. Okay. So let's go to number 1.3.2. So what evidence suggests that this valley is situated in the southern hemisphere? So what shows that this valley indeed is situated in the southern hemisphere? Okay. So you can see that this side, okay, is a south facing slope, and this side is a north facing slope. Okay, this side. So if ever you can see that this is a north facing slope and this is a south facing slope, right? So meaning that this slope here from this position downwards, downwards is facing southwards. So meaning that it's a south facing slope, and this on this side is a north facing slope, and this on this side is a south facing slope, and that one is a north facing slope because it's facing on that northern direction. I hope you get that. The reason I'm explaining this is that, well, in remember that in southern hemisphere, the north facing slope is the one that is receiving the sunlight. I repeat, in southern hemisphere, the north facing slope is the slope that is receiving the sunlight. However, in northern hemisphere, meaning that in countries that are in northern hemispheres, or regions that are in northern hemispheres, the south facing slope is the one that is receiving the sunlight. However, in this scenario now here, they said that this is the southern hemisphere, meaning that yes, indeed, it is southern hemisphere, because you can see that this is the north facing slope. Okay, north facing slope, it's facing northwards. Okay, yes, on that direction there. Okay, yes. So this slope is not facing slope because the one that is receiving the sun's rays, or the sunlight. Okay, as you can see. I hope you get it. Okay, so that's the reason. So that's the evidence. Okay, so that's one. Um, so let's move to 1.3.3. So explain why area A is referred to as shadow zone. So let's explain why area A is referred as a shadow zone. Okay, let's read that. Why area A is referred as shadow zone. Where's area A? Okay, so this is area A. So the reason why area A is referred as shadow zone, it's simply because it doesn't receive sun's rays of the sunlight. Simple, straightforward like that. So you know that shadow zone is the one that is moist, is the one that is not receiving sunlight, is the one that is in shadow because it doesn't receive those sun's rays, because it's facing on the opposite direction, which is the south facing slope. It is the south facing slope, and this is the southern hemisphere, meaning that south facing slope are shadow zones in that instance. Okay, so let's move to 1.3.4. So you are supposed to give one day. Okay, so let's go to picture marks. Explain how wind B will develop during the day. So where is wind B? So this is wind B shown by this arrow here. Wind B going upwards. You know that winds that are going upwards from the slopes, or from the valleys, you know that if it goes upwards, and this is during the day because you can see that we have sun's rays, right? Yes, so this is anapatic wind. So the question says now, explain why explain how wind B will develop during the day. So how this wind during the day develop during the day? So after the sun rays have hit the surface of the valley, meaning that the warm air, which is lighter, that warm air is lighter, so it's going to be oblique to rise. So that's what happens, or what forms slope wind A. Okay, yes, you can also add that also due to the terrestrial radiation, meaning that all the objects that have been heated now are releasing that heat. Okay, back upwards to go up there, to go up the hill. Okay, yes, so that's how slope wind A is formed. That's how it goes. So let's move to the last question, which is 1.3.5. So 1.3.5 says, in a paragraph of approximately 8 lines, give advice to a farmer on how to plan the usage of the land at place C and place D. Okay, effectively. Take into account the influence of aspect and resultant winds. Okay, so mean that you have to regard as to the influence of the aspect as well as the resultant wind. Okay, so let's advise this farmer. Okay, so let's that um, it's going to be effective because that many plants, that farmers, by the way, mostly dealing with crops, growing crops, etc. Crops are plants, and that plants, to most plants, or each and every plant, by the way, has to go under the process of photosynthesis in order to grow effectively, meaning that it's going to be vital for us to advise this farmer to grow their crops in this north facing slope, which is receiving the sunlight. That's number one. So you can also say that so that you also know that in this position here, this is the valley floor. Okay, that the valley floor, mostly in winter, will be dominantly covered by the cold, dry tensor. Okay, which will then cause which then will condense and cause the frost. Okay, yes, meaning that if ever it causes the frost pockets now, meaning that we have to advise the farmer to do what? To plant the only crops in winter that are resistant to the frost on the um on the on the valley floor. Okay, yes. You can also say that, yes, something that they have to grow crops that are frost resistant. Okay, yes. So you can also say that farmers will have to irrigate the north facing slope to successfully plant their crops. Okay, yes, because there is continually um, warm rising air, which will then cause the soil moisture content to lose, or we can say that the soil content to lose moisture. Okay, yes, on this north facing slope, so meaning that there will be more irrigation process that have to take place on this position. Okay, yes, on this north facing slope. Okay, so the other thing you can say that the farm still can be located on the higher slope as it is warmer. Okay, yes, so we know that the farmstead, the house of the farmer, must be on this place, because you know that at this position, that in winter it's warmer because um than in the valley floor, because there is an inversion layer there. There is warm air that is trapped around that position. Okay, yeah, can say all of those things. The other thing, the last thing that you can say is that so soils on the north facing slope is also drier. Okay, yes, as it results to higher levels of evaporation. I've explained that one. Okay, yeah, so you can just say those specifics. Okay, yes, yes. Um, okay.